The first question I chose to solve for my student-directed study was under the Kinematics unit under Projectile Motion. The question is, a person kicks a soccer ball with an initial velocity directed at 53 degrees above the horizontal. The ball lands on a roof 7.2 meters high. The wall of the building is 25 meters away, and it takes the ball 2.1 seconds to pass directly over the wall. The first step in solving this question is to draw out a diagram so you can see what is happening. In this diagram, we can see the ball was kicked 53 degrees above the horizontal from 25 meters away from the wall. The wall is 7.2 meters tall. There's this space between the wall and the ball, and it takes 2.1 seconds for the ball to completely pass over the wall to where it lands. Okay, so the first part of answering the question is to calculate the initial velocity of the ball. The first step in doing this is splitting all of the known variables up into the vertical and horizontal aspects. So in the horizontal is the one that we'll focus on right now. You know that it takes 2.1 seconds. The dx, the change in displacement over the x, is 25 meters, and your change in velocity in your x direction is what we're looking for. So to solve for this, we will use Vx is equal to the change in displacement in the x direction divided by your change in time. So we input the numbers 25 over 2.1, and we get your v at x is equal to 11.905 meters per second. The next step is to use this triangle, which shows that our initial velocity is equal to your velocity in the x component squared plus your velocity of the y component squared, which is the Pythagorean theorem. So in order to find your overall initial velocity, which is your hypotenuse, you can use SOHCAHTOA, which we would use cosine. So the cosine theta is equal to your adjacent divided by your hypotenuse. We know that our theta is 53 degrees. We know that our v at x is our adjacent, and our vi is our hypotenuse. So we input the numbers. We have just found the vx up here. So we input our numbers, and we get your initial velocity to equal 19.78 meters per second. Now, the one thing we need to keep in mind when answering questions in physics is the significant figures. So when we write our concluding sentence for this question, we say the initial velocity is 2.0 times 10 to the power of 1 meters per second, 53 degrees above the horizontal. We use two significant figures because in the overall question, the lowest number of significant figures used is 2. The second part of this question is to determine the horizontal range of the ball. So the first step is writing out what we know. We know that the change in dy is 7.2 meters, which is your change in height from your wall. We know your acceleration is negative 9.8 meters per second squared due to gravity. And we know your initial velocity in the y direction is 19.78 times sine 53. This is because we used this right triangle that we had in the other question, and we found our initial velocity in that other question, and so we can use that information with the sine to find your Vy, because sine is opposite over hypotenuse. Okay, so that's how we find your initial velocity in the y direction. So we use this information and we input it into this equation. Your change in displacement in the y direction is equal to your initial velocity in the y direction multiplied by your change in time added to 1/2 of your acceleration times the change in time squared. Now you can put in all of the numbers, and what it comes out to is 4.9 meters per second squared change in time squared, subtract 15.797 meters per second change in time, plus 7.2 meters is equal to 0. This is a quadratic formula, or a quadratic equation, and in order to solve this, we need to use the quadratic formula, which I have written right there. So, in order to know what variables put into where, your quadratic formula needs to be from your highest exponent, so t squared, to your lowest exponent, which is nothing. And this is your a, your b, and your c. So you put that into your quadratic formula and you solve for t. Now we get two answers when we use the quadratic formula. We get t is equal to 2.67 seconds and 0.549 seconds. We need to omit the 0.549 seconds because it is too small to be logical for the answer. So now that we have the time it takes for the ball to land, we use this formula. Your d at x, which will be your horizontal range, is equal to your initial velocity times cos theta times your change in time. So we input the values that we know, your initial velocity, cos 53 degrees, and 2.67 seconds. You get 31.78 meters is your change in displacement in the x direction. You need to take into account sig figs, which is still two significant figures, so your horizontal range is equal to 32 meters. The last part of answering this question is to determine what distance does the ball clear the wall of the building. So what is this distance up top? We need to list all of the things that we know. We do not know dy, that is what we're looking for. We know your initial velocity is 19.78 meters per second. We know it takes 2.1 seconds to get to the wall, to pass the wall. And we know that your change in displacement in the x direction is 25 meters. Your acceleration is negative 9.8 meters per second squared, and your theta is 53 degrees. We can use this equation. Your displacement in the y direction is equal to your initial velocity times sine theta times change in time. Subtract 1/2 of your acceleration or gravity, they are the same thing in this instance, multiplied by your change in time squared. Now we can input all of the values that we have figured out, and we get 11.56 meters. Now this answer, the 11.56 meters, is from the top of this line, the ball, to the ground. So what we need to do in order to determine what the ball clears the wall of the building at, we need to subtract the height of the wall. So we subtract it by 7.2 meters, and our answer is 4.36 meters. Now we need to include significant figures once again, so our concluding sentence is that the ball clears the wall of the building at 4.4 meters.